In past tutorials, we learned how to rig an entire arm using Adonis. However, it is true that the behavior of the arm might look quite stiff, right? So we can see here we prepared this animation, and in this animation the arm is, it's simulating, but at the same time is very, very stiff in how it reacts to the movement of the arm. So in order to change that, we have a series of attributes on our solver that allows to do just that. For instance, we can change, let's change here for the biceps. We can use a custom stiffness. So instead of the muscle stiffness, which is 5,000, we can set a stiffness of 1,000 and simulate again. And you can see that now the bicep is freer to move and has more secondary dynamics. Now let's turn this off. Another way to achieve a similar result is to use the constraint stiffness overrides that are very, very specific to the different constraints that you might be defining. So for instance, attachments in how we build this arm are really what are making, are emulating the effect of the internal fascia all surrounding and external fascia all surrounding the muscles and keeping the muscle in place against the bone and the other muscles. So here I can set a stiffness of 1,000. Sorry, let's make sure that we have these back to whatever it was supposed to be. And now we can play these back. And again, we see the dynamics of the biceps. Now we can go all the way down to 100 and still seeing, how the behavior is affected. Obviously, if we go very, very low in the values, then we have to reconsider our maps to be a little bit more, a little bit stronger in how the attachments are set in certain parts. But for instance, with 500, we can see proper dynamics on the bicep. So what we can do is that we can come here and say, for instance, hey, look, let's select all of these. Let's go to the channel box and let's look for those attributes. So I can set all of them to, let's see, where are you? Attachment to geometry stiffness override. Let's set them all to 500 and let's play back our simulation. And now you see that we have a way more dynamic simulation happening.